In 8.1, we're going to do a review of right triangle trig. Hopefully it's review. If I have a right triangle is made up of a hypotenuse, which is the longest side, and then two legs. So both of these are called legs. Okay. And then a right triangle has a right angle, and then it has what we call base angles, and those angles are each smaller than 90. Trigonometry is the study of the relationships between the sides of a triangle and the angles of a triangle. For instance, let's say I took this point and I pulled it out in that direction. If I did that, I would create a new triangle, and notice as I lengthen that bottom side, the angle up on top gets bigger and the angle on the bottom gets smaller. So as we stretch and pull a right triangle, the angles change with relationship to the side length changes. So when we're dealing with trig, we have to name the angles and pick one of them. So let's call this one angle A and this angle B. Okay. So if I select angle A, and often we use the variable theta, that's a Greek letter like alpha, beta, gamma, delta. It's just, that is a lowercase theta. It's just a letter in the Greek alphabet. So let's choose angle A. If I choose angle A, of course, the hypotenuse is always the hypotenuse, but we need to name the two legs with relationship to A. So the side that does not touch A is called opposite. And the side that does touch A is called adjacent. Okay? And what happens if instead of choosing A, I choose B? Now, this is adjacent, and this is opposite. So the angle you choose dictates which side is opposite and which side is adjacent. And then the hypotenuse never changes. What happens if I choose the right angle? So let's choose this one. Yeah, now we have two adjacents, and then the hypotenuse is also the opposite, and it wrecks everything. So we are not going to choose the right angle. Now, there are other formulas out there that allow you to choose the right angle, but not in this chapter. Okay. So if I have this triangle, and let's call that angle theta, there are 6 different ratios that I can build. So trigonometry compares the size of an angle to how long the sides are. But whenever you compare sides, you need to do a comparison between two sides. So you could say 4 divided by 5, or 5 divided by 4, or 4 divided by 3, and so on. There's 6 of them. So in trigonometry, we define the sine, which we abbreviate as SIN. Don't say sin or I'll laugh at you. The sine of theta is the O side divided by the H side. So if we pick angle theta, the sine of angle theta is the length of the O side divided by the length of the hypotenuse. So in this case, it would be 4/5. All right. The next ratio is called cosine, and we abbreviate it as COS. Don't say cos or we'll laugh at you. The cosine of theta is defined as the A side divided by the H side, which in this case is going to be 3/5. And then the next ratio is called tangent, which we abbreviate as TAN. Don't say tan or we'll make fun of you. The tangent of theta is the O side divided by the A side, which in this case is going to be 4/3. You need to memorize those ratios, but it's really easy. We use the mnemonic SOHCAHTOA. So sine is O over H, cosine is A over H, and tangent is O over A. How do you remember that? Somebody taught me this once and you'll never forget it. Some old hippie caught another hippie tripping on acid. There you go. You'll never forget it. Okay? All right. Here's a right triangle. What is the tangent of C? So tangent uses the O side divided by the A side. So if I choose angle C, which side is opposite C? 12. And which side is adjacent? Would be 8, which is going to simplify. We pull a 4 out of each of them. And we get 3/2. Okay. What about the cosine of D? So we go to angle D. Cosine is adjacent. Which side is adjacent to D? 12. So 12 divided by 13 is the cosine of D. What about the sine of C? So we go to angle C. Which side is opposite C? 12 over 13. Oh, what do you notice? The cosine of D is equal to the sine of C. And that's always true. Okay? All right. Does that make sense? You guys have seen this before, right? Okay, let's hit some Alex. All right. All right. Here's a right triangle. Cosine of B. Don't forget SOHCAHTOA. So the cosine of B is going to be 8 over 17. The tangent of B, 15 over 8. Sine of B, 15 over 17. All right, problem 2. This wants to know how big is the tangent of 79. So if I had a triangle and this was 79 degrees, what is the tangent of 79? So that's going to be the opposite side divided by the adjacent side. Well, how many triangles fit this definition? How many right triangles are there in the universe that have a 79-degree base angle? An infinite number, right? Little tiny triangles, big huge triangles, and everything in between. So what this is saying is, for every triangle that has this shape, so it could be smaller, it could be bigger, for every triangle that has this shape, what is the length of the opposite side divided by the adjacent side? Well, we need to ask our calculators for that answer. So in your calculator, you need to make sure that it's in degrees. So for this calculator, if I push mode, the fourth one down, I have the option to choose radians or degrees. There are 2 ways to measure angles. One of them makes a lot of sense in the physical world. and that's degrees. One of them makes a lot of sense in the theoretical world, and that is radians. But nobody measures angles in radians in the real world. Right? There aren't any protractors that you go out and measure angles with in radians. So we're going to stick with degrees for now. If you have one of the blue calculators, you'll either see a little RAD on the screen or a DEG. Make sure you're in DEG. All right. So we want to know what is the tangent of 79. So I just type in tangent of 79 and I get 5.1. What does that mean? It means for every triangle that has a 79-degree angle, so I have this triangle with 79 degrees, the length of the opposite, that's a bad triangle, the length of the opposite is 5 times bigger than the length of the adjacent. So this could be like 5 and 1. Or if it's a bigger triangle, this could be a 10 and a 2. Or if it's a really small triangle, it could be 0.5 and 0.1. So we were just saying, what is the ratio? If the angle is 79 degrees, how long is the opposite in comparison to the adjacent? And in this case, the opposite is 5 times bigger than the adjacent. So you just use the sine, cosine, and tangent buttons to solve all of those. Okay, problem 3. All right. In this triangle, we know one of the angles is 44 degrees. We know that one of the sides is 13. What is the length of the hypotenuse? Which ratio do I need to pick here, sine, cosine, or tangent? Well, what two sides are listed? O and H. Which one uses O and H? Sine. So the sine of 44 is 13 over x. Okay, now I'm going to draw another triangle. Let's say I had this, and I had x over 5. Which ratio am I going to use there? Tangent. So the tangent of 10 is x over 5. So when you solve these problems, you are either going to have the variable in the denominator, or you're going to have the variable in the numerator. So in this second problem, what do I need to do to get x by itself? Multiply by 5. We're going to refer to that as a multiply problem. If the variable is on bottom, how do I solve for x? No, well, I mean, that might work. It'll take us a while to get there. The easiest way to do it is to switch places with those. X equals 13 over the sine of 44. We will refer to these as switch problems, and we will refer to these as multiply problems. So for the switch problem, I get 13 divided by the sine of 44. And x is 18.7. Okay, on the other one, I had 5, was it 5? 5 tangent of 10. So 5 tangent of 10, and I get 0.88. Okay, let's do another one. Okay. Which trig ratio am I going to pick here? Tangent. So the tangent of 33 is x over 10. Is this a multiply or a switch problem? multiply. So I multiply by 10, and my answer is 10 tangent of 33. So 6.5. Okay. Which ratio do I pick here? So I know the A side, and I'm looking for the H side. Which one uses A and H? Cosine. So the cosine of 68 is 18 over x. Is that a multiply or a switch problem? Switch places with those. So we have 18 divided by the cosine of 68, and we get 48. Okay? You guys good there? All right, problem 4. Okay. Here, we are given one angle and one side, and we need to figure out everything else. Well, angle A is going to be the easiest. What do I know about the two base angles? What do they add to? Well, every triangle adds to 180, and one of the angles is already 90, so the other two must add to 90. So if one angle is 50, then angle A is going to have to be 40. Okay. Now, if I want to find side A, what ratio do I use there? That would be opposite and adjacent, so tangent. The tangent of 50 is 23 over A. Is that a multiply or a switch? Switch. So A is 23 tangent of 50. Okay. So 23 over the tangent of 50. And I get 19 point, what does it want? Nearest 10, 19.3. So side A is 19.3. Now, if this is 19.3, can I use the cosine? And the answer is yes, but I wouldn't. What's the problem with using the cosine? You see a reason why using the cosine might create issues in ALEKS? Well, it was actually 19.29936, and I had to round it. So if you use an imperfect number to generate your new numbers, then you might be off by just a little tiny bit. So instead of using that one, I would use 23. Okay. Now, are they going to have unknown angles in here? Let's look. Because that's going to cause us some problems. No. Okay, I think we're good. Okay. How are we going to solve this one? So tangent is going to be opposite divided by 8. But I don't know what the opposite is, so how do I find it? We have to use our good old friend a squared plus b squared equals c squared. Which one is c? The long one. And the other two don't matter, right? A and b can be switched. So in this case, let's call this x. We have 8 squared plus x squared equals 17 squared. So that would be 64 plus x squared equals, I don't remember. What is it? Oh, good. 289. Thank you. Now what? Subtract 64. So we get x squared equals 225. And I square root that, and I get 15. So what is the tangent of theta? 15 over 8. Now, what if this would have been like 200? Does 200 square root nicely? No. So you just write the square root of 200. Okay. Let's see if there are more that... Okay. That is as far as we need to go today. All right. Get to work.